este sistema Metigo Map, que va a ser motivo no solo de la conferencia del día de hoy, sino de una serie de actividades que están programadas esta semana en torno exactamente al sistema Metigo Map y a todas sus características que lo hacen ser un software francamente muy interesante para la conservación del patrimonio cultural, tanto bien inmueble como bien mueble, que seguramente podrá sernos pues una herramienta no solo de registro, sino de un registro administrativo, de un registro muy amplio, muy sistemático, muy profundo en términos de lo que es un mapeo de alta resolución y de alto cumplimiento en todo lo que son pues, los relieves, estructuras, con lados múltiples, y además todo lo que esto implica en términos de los levantamientos e integración de información para un sistema que, además de sernos útil para tener un registro absolutamente documentado, del cual, como sabemos, se deriva una factibilidad de aplicación en términos de la organización de proyectos, de la administración, de la cuantificación, y que finalmente presenta una serie de características que nos resultan a todos francamente muy interesantes en términos de una más ágil, más adecuada documentación y factibilidad de derivar de muchísima información. Por tanto, la verdad es que agradecemos de veras profundamente a Gunnar Sidler, que está con nosotros en México, en el Instituto Nacional de Antropología, tanto en esta Coordinación Nacional de Conservación como con la Escuela Nacional de Conservación, Restauración y Museografía, con quienes obviamente estamos trabajando en colectivo para hacer posible la difusión de estos sistemas, de este tipo de software, que nos permitirá un registro y documentación, como decía, mucho más amplio. Hoy, como señalábamos, esta sesión pues será esta conferencia, y a partir de mañana empezará una serie de prácticas y de experiencias posteriores, por las cuales pues le agradezco también y está con nosotros Luis Carlos Bustos Reyes, que seguramente muchos de los que están aquí ya lo conocen. Él es el coordinador académico de la maestría en conservación y restauración de bienes culturales y inmuebles de la escuela, con quienes, por supuesto, estamos trabajando, y les cedo la palabra.
Gracias, Julio. Bueno, a nombre de Andrés, que es el director de la escuela, hoy en las ocasiones, también estaba ocupado atendiendo otras cosas de la dinámica administrativa de la escuela. Sin embargo, sí hacer presencia, entender que desde la perspectiva de la formación, ya desde hace un buen tiempo en nuestro país empiezan a aparecer una serie de plataformas y programas desarrollados buscando ahorrar mucho tiempo, pero no solo mucho tiempo, sino buscando integrar un montón de cosas, ¿no?, que siempre tenemos en la cabeza para desarrollar, y que en el sentido de las posibilidades de desarrollo, si antes se invertía mucho tiempo y se iba implementando una serie de como cuestiones artesanales, es decir, y se va trabajando de una manera muy artesanal, recuperando, generando toda esta información, tener la posibilidad de una plataforma que sintetice todo el trabajo que también que desarrolla procesos de comprensión es muy valioso. También es un reto pensar ahora cómo no perder esos procesos comprensivos si vamos a empezar a tener una relación, ¿no?, estrecha con este tipo tipo de programas, también es algo importante. Sin embargo, la tecnología y estos desarrollos se van a hacer presentes. Es una necesidad empezar a utilizarlos, incorporarlos en la formación para la restauración, para la documentación, pero sin perder de vista que la parte humana que opera todas estas cosas y que hace los procesos más significativos para la conservación del patrimonio, no se puede perder. Entonces, hay un reto importante siempre en la academia de entender cómo detonar estas experiencias de aprendizaje de estas plataformas. Empezamos, se va a empezar a diseminar el conocimiento de Metigo Map como una alternativa para nuestra labor. Y bueno, junto con eso iremos aprendiendo y entendiendo cómo en los procesos formativos podemos ir dándole valor a esta parte sin perder, ¿no?, todo el valor que tiene la persona que recupera la información, que la trabaja y la procesa a través de todas estas plataformas. Gracias por venir a traernos todo este desarrollo. Gracias a Marielle, que siempre su iniciativa de vincular todas estas cosas es muy valiosa esa inquietud. Y al final, pues nuestra comunidad detona cosas importantes. Gracias, Marielle.
Bueno, a mí solo me queda como dar también agradecimientos a pues esta idea o este sueño que empezó hace 2 años. Me gustaría nombrar a una restauradora que es egresada de esta escuela y que empezó desde Alemania a hacer el vínculo con Gunnar Sidler. Ella es Sandra Bucher-Hilza. Ella pues empezó a hacer este enlace dando una primera conferencia acerca de nuevas tecnologías. Creo que este tipo de programas finalmente nos acercan pues, a la vanguardia de los registros, la documentación, la toma fotográfica del patrimonio cultural. Entonces me parece que están como enterados de qué está sucediendo en el mundo y tener también la capacitación para ellos es muy interesante. La otra cuestión que sería muy bueno que pudiéramos generar en todos estos días del curso es que estamos restauradores de bienes muebles y restauradores de bienes inmuebles como una sola comunidad. Entonces va a ser muy interesante que podamos estar desde también la perspectiva institucional, la perspectiva privada, y que podamos generar diálogos, comunicación entre nosotros, que creo que también eso es muy importante. Muchas gracias a todos por estar aquí. Muchas gracias también a Liliana, a Andrés Diana, a Luis Carlos Bustos, porque sin su apoyo no hubiera sido posible. Y muchas gracias, García. Okay. ¿Lo dejamos juntos? No, la palabra.
Good evening. Nice to see so much people. My name is Gunnar Siedler. I am an engineer for surveying and photogrammetry. I am a conservator and we provide services for conservation. We make documentations for conservation architects. And I give you today 3 presentations. In the first step, I show you the work in the field of photogrammetry for conservation. It's interesting to understand at first which type of documentation the conservators in Germany use for documentation, use different programs. Yes. Which type of quality we produce in the field of documentation. We start with our firm in 1993, and for a long time we produce the services digital in the office, and then we print it out, and then the conservators take the pen and make the mapping by mapping. And in the time of, I think, in the end of the 90s, around 2000, we get 32-bit systems by Windows, and we can buy digital cameras, and there was a change in the usage of digital data. And we started to develop the software for conservators. That they can make specifications for their small one projects, and then we can start to make some. In the middle of the second part, I give a presentation from the other side, not from our service. Or you have to define the quality for documentation if you are interested in organize this. Yes, I give some features, what is necessary to get a good documentation. And the last part, I speak about Metigo Map. So, functions, give an overview over the functions. In the next days, you will see more on the training. So I can start with the first. Okay, this is also part of our work. We speak about 2D image rectifications, mosaicing of images. We speak about unwrappings, 3D documentations. We speak about the evaluation of historic photos and total station of surveying. It's only our work. We don't speak about this today. We make also for painting conservations, documentations by UV light or infrared. Okay, this was the beginning. The images are very old, in the 90s, maybe 94, 95. Where we start to make the first digital rectifications. And the first idea was we can make rectifications to get one plan, to have a mosaic to one plan. Yes, you see the roof, and you cannot take one image for the tower, so you must make on the left and put on the right side. You measure coordinates, you can make the rectification, and the conservator get one plan. This is the main idea, yes. Make rectification to make the mosaic. And if the project is too large, you come with a total station, measure coordinates over the wall, and you can make 4, 5, 6, 7 images and more, and the result is a mosaic of the images. And for a long time, we use large format cameras, 13 to 18 centimeter on class plates and 4 to 5 inch, and we scan these images. We measure the coordinates by total station, that's not changing in this. We make a high resolution scan and the rectification of the images. The mosaicing by colors we do in Photoshop since 20 years. And at the beginning, we speak about scale and resolution. What means resolution? Resolution 400 dpi, 400 dots per inch. That means 400 dots per 25 millimeters. 1 dot by 400 dpi is 0.06 millimeters. And then we take the scale and multiply this with the scale. So we understand maybe by a scale 1 to 5, you see 0.3 millimeters. Or by 1 to 10, 0.6. Or maybe 1 to 50, you see 3 millimeters for 1 point. That means at the beginning, before you start to make the documentation, we must define the quality of the object. The customers come to us and ask us for the price, how much will it cost for image quality, and so on. Depending on the I will talk more about this later. And in Metigo Map, we have a planning for photocopy. You select the size of the object, how many meters, the width and the height. Then you select the scale and the resolution. We calculate for you the size of the image pixel on the side of the object as in the scale 1 to 1. And then you can make the decision, is it enough, I need more resolution or not, must I change the scale? In the next step, we take the size and the scale and the resolution and we calculate the size of the image, how large is the image. And then you can select one of your cameras, you can select the sensor of the cameras. And we say to you, you must take 4 images to get this resolution. Before you go out to take the first images, 5 minutes to test the size and the resolution. And then you know what you have to do to get this. Yes, it's very easy. In our work, we work with total station, we use the total station, and so we measure coordinates on the wall. We work with flashlight or with daylight energy, polarization filters and so on. We have a lot of equipment. And then we make the rectification of the first image by these coordinates, and the next image, and the next. And then we can write out a multi-layer TIFF file. We go to Adobe Photoshop, you get the design. Maybe this is a wooden object in the scale 1 to 10, I think. And you see the resolution of this. 2D image rectification is a compromise. That means we define one plan. This plan has a scale. You see, this is the plan with the scale. And all things which coming out, they have a small mistake in scale and in perspective projection. They are a little bit more in sides, and if they are deeper, they are smaller. Yes? Then I go one step back. Sorry. You see the walls, it means these parts are the scale, and the window, it's only for nice viewing. Yes, we make the photo in front of the window. There is no scale. And for the documentation of conservation, we make an extra rectification for the windows and the side left and the side right, the side left. Okay. It's an example for this great wall. It's not possible to take images from one position. Yes, we must go to the next house and we take some photos for the second floor, and we must go to the balcony. Take the photos, and you see the rectification. This is a part of the images. You see one original image. And you see the complete wall. And this is in the time of 1998. That means we print out these parts, these segments, on the sides of format A3, 42 centimeters 29, for the analog mapping, yes? And later we get some digital image. It was for a long time that normally worked. Okay, the next, sometimes it's not only enough to calculate how many images we need to get the resolution. Sometimes we must do more images to follow the structure of the object, that we can make the good mosaicing. You see the paintings in the middle, so it's necessary to make one image only for the painting. So we can follow the structure of the thing. And you see the result. It's the same. Yes, we take one image before the window, one image before the painting. It's the next, it's the next. It's only a question of working time. We must discuss this before with the customer. Is it too much work, too much cost? Or should we take maybe every 2 windows, one image, depending on the project? It's the same. Yes, you can do only one image, but we do 3 images. So you every time look in front to the window. Yes, so you have a good feeling of good documentation. And sometimes the people use this for, you see, it's enough for mapping if there's not much things to make for documentation. And sometimes we make special mappings for the window, depending on the project. Maybe you have seen the printing out of the marble floor. It's a room 30 meters to 20 meters. And we have to take over 50 images. This is one image, 4 to 5 inch. And scan with 2,500 dpi. This is one image with 10 to 12,000 points. And then we have measure coordinates, we have made rectifications. And then you see the small fields. That means we have to print out every stripe 1 to 1, 1 meter to 2 meter 50. And the problem is the house is in the time of 17, I think 77 year or 18 years. And they have cut the marble inside in the house with water. And every time they have problems with the wooden structure. It's too much water in the ceilings. And now they must open this part of the floor to bring a new construction by steel below of the floor. And thereby we have to print out the stripes so they can take the segments, put them on the stripes, and take it back. Normally we make no documentation 1 to 1, normally 1 to 10 or 1 to 20 years. For this project we have done this. This is one stripe, 1 meter, 2 meter 50, and this is the resolution 1 to 1. And you see the problems, they must do a lot of repairs. Okay. We go to castles or to museums, and normally we come and make the complete documentation of one room. They need a lot of time to remove all the things, the equipment and the objects, yes, and then we have 1 or 2 days time to take photos from the floor, from the ceiling, and all the wall. And then we finish the work and they get a DVD with all the image plans, normally 110 or 120. It's a little bit depending on the material, which detail you need to see it. This is a single documentation of one floor. And this is only the nice image for the architect, not for the conservator. Yes. Like to see this. We have makes the documentation of the room, and so we have put some scale on. Okay, this was the first example was only for rectification by 2D for one plan. And now we speak about unwrapping of curved surfaces. You see the tower. Yes, it's like a cylinder. And we go out with the total station and we measure at first the horizontal section. That we know the position of the cylinder and the size of the cylinder. And then we're going around taking photos and we measure 3D control points. Now we need 3D control points so that we can calculate the position of the camera and the direction of the viewing. We speak about the photogrammetric orientation of the camera. And then we know the position of the cylinder, and we know the position of the camera, and so we can project the image data to the cylinder, and we can calculate this unwrapping. Normally, yes, and we can do this outside, we can do this inside, it's the same, yes. And the people say it's interesting to have one plan, to make one mapping, and to get an overview of the condition of the whole object. And we can do this with daylight images and with UV light images or with historic images. And so they get the combination of different types of images, they can put them together, they can overlay them, and they can make the mapping in one mapping project. And switch on off maybe UV light or daylight. That's why we make the mosaicing of curved surfaces. It's a little bit more work for documentation, but later they save a lot of working time. It's easier to make the documentation concepts. And you have a good overview of the project. It helps to understand the images and so on. It's the same, it's unwrapping. From inside, yes. 3 images, measure coordinates. Okay, it's a baroque. I think you have the same things here. You see the church, you see the baroque cylinder. And this is one image. We have measured the coordinates for the calculation of the orientation. And here you see the projection of the cylinder for the first image. And then you see the unwrapping of all these images. That means for every section we take 3 images, one to the left, one to the right, and one to the top. That we have a good resolution to the images. And then you see the sprite for 3 images. It's depending on the scale which we should do. And then we count the images and we can see how much it costs. And this is the result. Sometimes, okay, at first we have to speak about 2D rectification for plans, yes. Then we have to speak about 2D curved surfaces, yes. It's nearly 2D. It's a curved surface, but it's only a cylinder surface. In the next step, we speak about 3D auto projections. And we need the support of laser scanning that we can measure the surface and then we use it. Okay, you know there are different types of laser scanning. It costs a lot of money, and I think you have also see a lot of bad documentations by laser scanning. Laser scanning is good to measure deformations, in my opinion, or to draw some horizontal vertical sections. But it's not a good tool to make the documentation for conservator, because resolution is not good enough. So we must, before the project we start with the documentation, we must make a discussion when we need the laser scanning. We need it for deformation analysis, then we take it, and we need it if we make 3D auto projections. For this we use laser scanning, not more. We have some problems in the accuracy of the measurements, yes, by laser scanning. If you have industrial projects, you can use mathematical filter functions and you can correct it. If we have a monument project, nobody knows these are profiles in the stone or damages, or so we cannot use such functions. And you see the problems by laser scanning is one laser scanner from the left side, one from the right side. And this is normally one line, but the measurement from two directions gives you two results. And so I say normally laser scanning is good enough for documentation in the scale 1 to 50, 1 to 100, not more. By the accuracy, yes. If you go to the reseller of laser scanners, they speak about accuracy in the field of millimeters, but it's not correct. It's a small test with laser scanner from a German university at Access. You see this object, and you see it's like a Siemens star, yes? And normally, we have two surfaces. We have this surfaces before, and in the background, we have the second plate. And we take the laser scanner, and normally we should have two black lines or points on the first surface and on the second surface. And now you see the result of the different types of laser scanners. You understand? It's terrible, yes? I think maybe this can be the best one, but you see a lot of points between this, yes? And you see this, it's terrible, yes? Or like this one, it's not a result for laser scanning. If the reseller of laser scanners speak about accuracy, they mean, how can I say, the measurements in the laboratory. They have white walls and they have defined control points. They have special functions to measure control points in high accuracy, maybe white balls or special targets, yes. Then they make transformation between these points and they get results with 2-3 millimeters. The problem is, laser scanning is depending on the reflection of the surface. And we have a lot of different problems. The first, we have white and black stone. So we have different reflection and distance. If you make a measurement by black and white marble floor, you get difference in the distances 1 to 2 centimeters. By a measurement distance only of 2 or 3 meters. That means the color is important for the reflection. The next is the structure of the surface. If you have a fine structure, the next problem is if you have water on the surface. If you have maybe biological things on the surface. And it's also very important the angle of the measurement. So we have so much problems, and you see the result of this. And that's why I say 150, 100 is enough, no more. This is not an architectural laser scanner, this is done by an industrial laser scanner. In Germany, you must pay for this over 100,000 euro. It's too expensive for documentation in the field of conservation, yes, we cannot afford this. And sometimes we can rent it by firms who works for car production. In this field, they have enough money to buy this. And we have done this only for reconstruction of the profile lines. They have some stones, they will repair the stones, and they will reconstruct some stones. And so we have makes some scans to get the profile lines for the stones. Now we speak about the usage for the scanning data for us, for our work. You see the surface of the laser scanning. We make 2 images, and we measure coordinates to orientate the laser scanning data and to orientate our images in the same coordinate system. And then we use the surface of the laser scanning to calculate an auto-projection. And now we have no perspective mistakes in the data. Now it's an orthogonal projection of all. You see the lines of the stone are horizontal. You can compare this. This is 2D image rectification only on this plane. And you see the mistakes in the window. And you see the auto projection. If the architect comes and is interested to draw a plan, he's very interested to get this result. For the stone conservator, normally it's too expensive. The cost relation in Germany, we say it's 1 to 3. We need 3 times more money for buying the scanning data, for the orientation of the images and so on. And the conservator can take his own image, use our software, he measures the distance to the width and the height, so he can make the rectification. And for 3D objects in the field of stone conservation, they must make a documentation of manual measurements. So it's not necessary for him to have this high quality of auto projection, because the deep I can also not measure here. It's interesting to see the height, but it's also not measured, possible to measure the DPS. And so we must discuss this every time if we use it or not. It's a question of money and working time. Sometimes architects use the auto projection by the intensity of the laser reflection. Yes, the measurement of the, if you have a white wall, you get more reflections than on a black wall. And so you can calculate a grayscale image by the intensity. And this is only through the rectification. Now there's a problem. You see the surface of the laser scanning information. For the architect, it's good enough to draw a plan. Yes, you must make it different. But for the stone conservator, it's nothing. He needs the image on the right side, and he do not need the exactly auto projection of the stone. He's much more interested to see the details, maybe the damage in the stone. You understand? Okay. So now I show you some examples for the usage of auto projections. You see the ceiling of the room, the surface, and then I can take one image, and now you see not the rectification on the plan, it's the correction over the whole surface model. Yes, and the first image, the next, and the next, and the next, and the next, means they have all the same geometry. And then we can make the export as a multi-variative file to Photoshop. It's the same if you have curved surfaces with different directions, yes, and multi-curved surfaces like this. You see the ceiling of the church, and I have one direction of this. This is the mean cylinder for the unwrapping. And we have also these directions. And it's not possible to make a mosaicing of all these images which we need. And so we use the surface model, and this is one oriented images. Now you see the result over one ceiling. I think it's, if I see this, maybe in Germany, 6,000 to 8,000 euro for this image plan. It's a lot of money, yes. And if you go to the church to build the scaffolding that you can work at the ceiling, it's much more money. Yes, every time you must make a relation to the costs for the whole project. And then you can say maybe 1 to 3% can be used for documentation. You must see the relation. How large is the project, how much money we can use for documentation. And so I think for the ceiling, it's not much money. So you need much more money for conservation, for organization, for scaffolding, and so on. And they save a lot of working time to use this plan for documentation. So you can calculate at first how many square meters we have to repair. The next step, you can make the documentation. They take a lot of working time, and they can organize the cost, and they can organize the work. This is a resolution. If you look to the detail, you see some problems by laser scanning. Maybe if you look to these edges, it's not possible. Okay, but you recognize, yes? It's the same example. It's bridge stone from 19th century. Yes, it's not for, what can I say, not for cultural heritage. We do this for architects. They are only interested to get a good image plan, to organize the work, for repair the joints, and for exchange the stones. That's all. This is the result. This is an auto reaction. Yes. Sometimes you must calculate the compromise before. You see this room. We have made the laser scanning to use it for the ceiling. We have looked to the auto projection. We have said it's not good enough. So we have said for the walls, we make only 2D image rectification. This is only 2D with perspective. It's no problem, but in good resolution. And we use the scanning data for auto projection of the ceiling and for unwrapping of this on the scale 1 to 10. The floor, we make 2D image rectification, we measure all the coordinates. And we use the scanning data for the analyzing of the deformation. You see the problem in the wooden construction, like here, 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 as you know, where they must work. Okay. It's a complete documentation of the rooms, the floors, the walls, and the wood and the ceiling. It's it's on site, I think 2 or 3 days work. Taking the photos, measure the coordinates, and make the scanning data. And then we have, I think, 2 weeks work in the office. It's an example for the combination of daylight images and UV light images. That means we use this 3D surface model that we can calculate the orientation of the images from today. We make also UV light images from today, and we can also use historical images from the times from 1940 until 45. They have started in Germany during the World War to make documentation with color slides of all war paintings. The thinking was we can repair this later, yes. It's strange, but today it's a good documentation, yes. So we calculate the image from today and the image from 70 years ago, and the same quality. This is the result of the unwrapping of the ceiling. This is the detail. This is clear 1, 2, 5. It's from medieval time, I think, 1100 from this time. It's nice. This is an example for deformation analysis by laser scanning. You see the noise and the points, but if you go some step back, then we see the deformation. For this is a good example, yes. The image plane in the background we have made with 2D image amplification. Okay, that's example for deformation analysis. We measure. At first we make the scanning, then we measure profile lines automatically by the data of the scanning. And then you can see the changing in the walls to prepare. Okay, we go to the next. We speak about stereophotochrometry. It's a little bit history. Yes, for a long time, I think from the 60s until the 90s. There was only one way to get good graphic documentations. We work with stereophotochrometry. We have glass plates, 13 to 18 centimeter. We make 2 images for the left and the right A. Measure coordinates in the object. Today, maybe you go to the cinema and you use glasses just to see the stereo 3D film, yes. And normally we have large, how can I say, a large stereo evaluation table. It's like the table of the sides. The cost maybe 200,000 euro, and you have 2 optic for the left image, for the right image, and you look through the optic and you see the 3D image, and you measure with a control point on the surface. So we make the stereo model from the first, from the next, and you see the 3D viewing on the object, and you can make the drawing. And I think it's too expensive for today. Today, normally, we make only 2D image planes. And sometimes we make drawing if we have problems for deformation analysis. But then we make the combination. We make not the drawings of the stones, we make only the mean architectural lines. And the documentation of the stones they can find in the image plan. So it's a compromise. Today we use stereo documentation for automatically functions to get 3D coordinates. It's an example. Yes, you see 2 images, 2 SLR cameras, it's Canon 5D. And this is a fixed stereo base for 1 meter. And the software will automatically find the connecting points, and we measure some control points on the surface for the scale. And then we can calculate by matching of identical points to 3D coordinates. And you get the surface from one model. And we can calculate the errors and the mistakes. So you make one model, you make the next model, you make the next. Then we can combine them to one surface model. So we can calculate the surface of the apps, and then we can use it for the auto projection of the apps. For us, it's economic decision. Sometimes we use laser scanning, and sometimes we use stereo images to calculate the surface. If we have a small church, it's easy to take some stereo images to calculate the surface. If you have a large church, it's easier to take laser scanning. We make the decision by working time because now you can. It's only a nice image. In Germany at the time, no conservator works in 3D. It's, I think, today we have software with 64-bit, Windows 7, Windows 10, and maybe you can buy for 500 or 4,000 euro a computer with 8 or 16 gigabyte RAM. That means you can work very easy with large images, only in 2D. If you are interested to work in 3D, you need OpenGL. It works on the graphic card. And so you must buy expensive graphic cards, for 2 or for 4,000 euro and more. And it's in Germany also expensive, too expensive for conservators. Really, it's not necessary. That means we work inside with 3D data to calculate auto projections. But the result of our work, to 99% is 2D image plan. So the conservator can work easy in the mapping software with 2D. That's reality. Sometimes at conferences you see a lot of presentations about 3D projects and so on. It's not reality. It's an example of the unmapping. It's the auto projection, and this is the unmapping of the colored and with daylight image, and then the next with 3 UV light images. We have 4 UV light lamps to make and you have the same result, nice and colored with UV light, so you can put them together and can make the mapping. It's the unmapping of the apps, and this is using 2 images to analyze the overpaintings and so on. Okay, you know this, I think. We can use digital cameras for the part of the UV light and also near infrared. And so we make also infrared documentations of the paintings to see the drawing before. Yes. Or we make the documentation by UV light to see the changing of the material at the time. It's a UV light image. It means in our software Metigo Map we have functions for automatic imaging. We make that first with our large image format, the image plan with daylight, and then we take the UV light camera we take small segments, and then we can make an automatic rectification on the base of the daylight image. Maybe this is the mosaicing of 24 images, but it's not so much work like you think. We use our daylight image and we can make automatically the rectification on the base of the daylight image. It's not difficult, it's easy. So it means you can do this alone. It's an example as daylight UV light. It's very easy to use our software for paintings, but how can I do it? At the time we have no much customers for painting conservation. In the education and also in the museums, they think it's easy to open it over Photoshop and take the image and to make some drawings. It's much difficult like our software. If you open our software, you must speak about scales and resolutions, and you must make the rectification, and a lot of people say it's too much. I must think too much before, I cannot stop. But I think in the training you will see it needs 5 minutes to prepare a project and then you can start. At the time you have no idea how you can change this. It's very easy to make the rectification by a rectangle for this painting. And then you can make the rectification of the historic image, of the UV light image. You can make the mapping in one project. I think it's a question of quality, yes, for documentation. It's not much working time. It's we use together with Asmus storyline. We have a mobile X-ray camera. So we come in to make the daylight and the UV light and infrared images, and he makes for us X-ray images. So we can go to the church, to the altar, and makes documentation. Or X-ray. These are examples of X-ray. Okay, now we speak about the evaluation of historic images. In Germany, we have 3 large libraries. They collected historic photographs on glass plates from the time from, I think, 1880 until the Second World War. They have taken photographs with glass plates, 13 to 80 centimeter or 24 or 44 centimeters. And the idea is if I have only one image, you can make 2D image rectification, like with daylight images, no problem. And you can use the daylight images for the rectification. And if you have 2 or 3 images, then you can also make 3D evaluations. So you can, maybe you can measure some 3D coordinates or profile lines to make the reconstruction of dimensions for lost segments. Yes? And we have very large format of negative. If I have a negative 13 to 18 centimeter, I can scan this with 1,200 dpi. So I have resolution from 13,000 to 18,000 points. With one class plate. It's much more than with a modern digital camera. And the class plate is stable, there's no change in 50 years or 100 years. It's a stable format. And it works with long focal lengths, so we have also no distortion. So for me, it's all perfect images, yes, for documentary. And this is Albrecht Meidenbauer. He was strange for his time. He works with a camera with 40 to 40 centimeters on glass plates. So must listen, 20 to 40 centimeters, yes. This was his cameras, and he had a small car with a horse, yes, and he prepared the glass plate one side, takes the photos and makes development of the glass plates. And he takes not only the nice view of the image, he makes the systematically, how can I say, documentation of the object from all sides. And so for me it's very interesting because I can, with these images, I can calculate 3D coordinates in the accuracy of 2 or 3 centimeters. It's possible, yes. This is the example of a class plate of Meidenbauer. You see the room, you see the detail, and you see the resolution of this detail. One class plate is very strange. This is an example for 2D. Maybe this is an image from the 90s. It was in the borderline between East and West Germany. That's why you can see this guy. And at first you take the image from today, and you can make the rectification by the width and the height of the room. It's easy to measure. And then you take the historic image, you measure connecting points, and so you can make the reconstruction of the lost paths. And then you can make the decision which elements you will make the reconstruction and not. This is an example for 3D. You see the church in 2013. I have done this in the last year. You see Meidenbauer class plates from different directions to the tower. And this part is construction from Woodman on Kammer. It was burning down at the Second World War. Now they have collected money to make the reconstruction of this part of the tower. And there are 2 things. It's not only to get the information for a perfect reconstruction, it's also interesting to know the sides and to calculate, how can I say, how heavy, that you make not a wrong decision to destroy the first part of the tower. There are 2 things. You must believe the real information to make not more damages. Okay, this is the resolution of the Meidenbauer image, yes, you see the detail. And this is the car. I think this is the car, the horse in the car. And now you see the direction of 2, 3 images, and I measure identical points in the images, and I can calculate coordinates. And the architect gets a list of coordinates in the first step. In the second step, I can make rectification by the knowledge of the position of the rectification plan. It's not necessary to measure 6 or 8 coordinates. It's enough if I have 2 coordinates, the left and the right. Then I can define the position of this plan. And then you see the rectification also. Also, in the next, it's more strange. I have calculated the height of this. Then I have defined the horizontal plane. Then you see the rectification of different images. And so I can calculate the horizontal section of this part. You understand? It's possible with different images. Okay. It's a very simple example. It's only a small church in the village. And they have lost all this, and they are interested to make the reconstruction of this small building. It's not much work. It's only one image, it's a postcard. And so I measure coordinates to calculate the orientation. I measure the position of the wall, and then we make all these rectifications for this segment, for this. Yes, you see the details, and you see the unwrapping of this. And then the painter can come, can produce one-to-one, we can put it to the wall and can repeat it. Okay, this was the first part about our work. You have some questions, or we'll make the next?
I have a question, please. What about all the measurements? Do you do all the measures by hand, or does the program just all the measures like you need?
So if we works, we measure by total station.
Okay, so you have to have that.
We have a total station, yes, we are surveyors, and I think it's not so expensive. Maybe today you can buy a total station for €10,000. It's a lot of money for a conservator, but in Germany you can rent the total station for 1 day. Maybe you pay €50, yes. And in 1 day you can measure a lot of points.
Right.
And I think it's cheaper than to measure 2 or 3 days distances as an object.
And is there like a minimum of measurements that you have to have in order to get like a perfect image? Or?
I will speak about this in the next presentation.
Okay.
So you can use the software only for rectifications by distances or by coordinates. I'll show you some examples. Okay?
Okay. Cheers.
So switch. Maybe we can open the door that we can get a little bit fresh air in the room. This is what is going. Now we speak about quality requirements for polychromatic service. How you can organize this if you try to get documentation, or if you order documentation. In Germany we have a lot of different terms, a lot of different qualities, and it should help to find a decision. Okay, we speak about basic parameters, the resolution and the scale, which type of measuring data, and the camera sensor. We speak about the evaluation mode methods with 2D image or 3D auto and so on. About image montage and layout, and we speak about some library options. Okay, maybe this is an overview. It's like, how can I say? It's not a rule, yes, we have no rules for documentation. It's our experience after 15 years. For which projects we get which contracts to make the documentation, yes. And it's a little bit depending on the material. Maybe it's interesting for you to look to the conservation part, yes. If we work for stone conservators, we work normally in the scale 1 to 20, 1 to 25, normally, yes. It's a resolution of 1.5 millimeter. So you see all the problems in the stone. If the project is too large or if the project is not so important, then we take also images in the scale 1 to 50, depending on how much money they have, and also depending on the work which they plan to do. Maybe if they will clean the windows, they don't need a plan 1 to 10. You understand? Yes, you must make the decisions. If we work for wall paintings, for movie paintings, we work in the field of 1 to 10, 1 to 20. a little bit depending on the size of the project. And sometimes we have, how can I say, important memorial paintings from medieval time. Then we work also on the scale 1 to 5. But only for this, yes. For baroque objects, we work 1 to 10, 1 to 20. Then for wood, I think wood objects, maybe they are not so old, they are not so important, so it's maybe 100 years old or 150 years old, but they need the resolution to see the details. Maybe if you will see the joint between the wooden parts, you need 1 millimeter resolution and more to see the condition of this, yes. And that's why we work in this scale. Yes, a painting is clearly need 1 to 1 normally. And so this makes the first decision. Yes, you see this table, you know this is a stone project or a mobile painting project, and so you can make the decision maybe category 1, 2, 3. A little bit depending on material and the importance of the project. And so it's very easy to find the decision. Yes, first step. You know this example from the first presentation. Now we speak about the types of rectifications. We speak about rectification by geometry, rectification by coordinates, and rectification usage of auto projection of laser scanning and usage of CAD drawings. Yes, it means you have 4 options. And the first one is define a rectangle at the wall and to measure the width and the height. And for a small church in the village, nobody will come to us and pay money for this. The conservator has their own digital SLR camera, they take images and they use distro measurement to measure the distances, and they make the rectification alone. For small churches, we get no contracts, they do this alone. They have learned this, it's not difficult. And the problem is, it's not easy to find a rectangle as a project. It's more interesting to work with horizontal and vertical parallel lines. You can, maybe you find the line by the roof or the line of this architectural line, yes. You will find horizontal lines with the object. And if not, maybe you can measure the distances and you can define with markers the horizontal line. It's also possible, yes. And the vertical line, you can use architectural lines, or you can take a plumb line. You know what I mean, yes. Take this small plumb line. It's very easy, you need 5 minutes to take 2 plumb lines on the feather, you have a vertical line. If you need the accuracy, yes. And as we speak about the accuracy, maybe we measure the distance 1 to 2 centimeters. And the definition of geometry, I think you make a mistake between 2 and 5 centimeters. Depending on the quality of the object, yes. And we have all objects, and so they have deformations, and they have no vertical lines. It's clear. This is the first way. If we have small objects, maybe paintings or small fragments or in mosaic, you can use the same functions. We have the rectangle. Sometimes the people don't use the information of the object. Maybe they have a plate, and they mark a grid cross on the plate, and then they take the object and they use the information of the grid crosses to make the rectification. So it's not necessary to measure. Yes? For painting, it's easy to measure this. And maybe you are in the church and you have a small fragment of a movie painting, and around this wide area. And then you define 4 points, and you measure 6 distances. So we can calculate the rectangle by the diagonal lines. It's 5 minutes more work, but you have a stable rectification. And the accuracy, maybe in this detail, you can measure distances 1 to 2 millimeters. And the mistake by geometry, I say maybe 2 or 5 millimeters. So you have a good quality for this. For small objects, you can work in high quality alone. You don't need support. Yes. This is our work. We take the image and we measure coordinates. The quality of the coordinates is 5 to 10 millimeters. And if you take the rectangle, you have no control for the rectangle. if we measure coordinates, if we have more than 4 coordinates, then we can calculate the mistake for the rectification. The error, that means every time I have control about my result. The software will show me which point had which error. Then I can switch off the point, or I can look for the mistake. Maybe I have measured the wrong edge of the stone. Yes. So we have every time control. And the next advantage, if I need 2 images, by the rectification by coordinate, every image knows the position on the large image plan by usage of the coordinates. And so I measure the coordinates and automatically the image goes to the right position. If you make the rectification by rectangle, you must move them together with identical points. And you make more mistakes. And if you do not find the, the vertical lines, so you have some problems in the overlaying area between the images. Because in the left image, maybe you have to make a small mistake 2 millimeters to the left and 2 millimeters to the right. So you have problems by making mosaicing of large image plans. That means if you work with single images, it's very easy to work with distances. If you have mosaicings of 4, 5, 6 images and more, please take a surveyor and they come one day to me and measure coordinates. And the rectification you can do alone. Yes. If you have laser scanning data, you can say, please give me the auto projection. You see this image from before, from the presentation before. Now you search identical points to the image. Maybe sometimes you have problems in the identification of the natural points because you don't recognize the laser scanning data. But now you have the correct position of the images. You have more support by the mosaicing of large image plans. And if you take every time the same point in the overlapping area, so you have no problems in the overlapping. I think it helps. If you have laser scanning data, you say, okay, it's not fine, but you can use it. You must take this part that you need. And if you have a CAD drawing, you must make the decision about the accuracy of the CAD drawing. We have 3 types of CAD drawings. The first one, it is a surveying by total station. And so we have the same quality by the control points. But the problem is, if I measure control points, then I take special edges, special points, which I can identify in the image and as object. If you measure a CAD drawing like this, maybe I can take this edge of this window, but maybe if you look in the image, it's not a clear edge, it's a round edge. And so you have some problems by identifying the points. That's why the accuracy is not the same, yes? Okay, if you have a plan by total station, you have, I think it's enough for 20 or 30 years old, yes? If you work with photogrammetric stereo evaluation, I think the plans maybe they are 20 or 30 years old, you have a large paper plan, you must scan this paper plan. I think they have a good accuracy, but I say 2 to 5 centimeters. It's 20 years old, yes, the technology is 20 years old, so you cannot compare this with today. And if you work with a drawing by architects, I say 5 to 10 centimeters, it's depending on the drawing. You can test it. Sometimes it's a good idea to make an overview image of the object. And you take the 4 edges around the object, then you make the rectification. And then you can control the position of the windows of the drawing. And then you get a feeling, is it only a painting or is it a good drawing? It helps to understand the quality of the drawings, yes? That's my opinion, yes? It makes a difference between single image rectification. You can work with geometry, I think 2 millimeters, yes, 5 millimeters, 1 centimeters. If the people come and ask me for the accuracy of the plan, then I say you can measure the half millimeter and the plan printed out. That means you can take this half millimeter, multiply it with the scale, and so you have the quality which we try to get. That means 1 to 100 is 5 centimeters. Nobody comes to us to order a plan 1 to 100. You can do this alone. And 5 centimeters you can measure distances, you don't need a total station, yes. 1 to 50 for large plans, maybe the house is 100, 200 meters long. It's interesting to work with coordinates to get this result, 2.5 centimeters, yes. For stone conservators, 1 to 20, 1 centimeters. And now I have shown you by geometry, it's a little bit depending on the size of the project. If it is too large, you cannot reach this accuracy, yes. For smaller projects, it's easy. By total station, we have a problem. We have the objective of the total station with a factor of 30. If I look through the object, I have the increasing of 30. That means I have a high quality of the detail looking through the objective of the total station. And then I take the image and I never see this quality. And so sometimes we measure points which you cannot find the same quality in the image. And so in the scale 1 to 2, 1 to 5, we work with matching functions of Metigo Map. That means if we have a painting, we make the rectification sometimes only by rectangle or by 6 coordinates for the overview image. And then the high resolution 1 to 1, 1 to 2, we make only the rectification by matching functions. Matching functions means the software search automatically identical points and the quality of subpixel 0.2, 0.3 pixels in the image. Yes. So it works with an area of 30 to 30 pixels to match the points. And so it's very easy to make the mosaicing of this image. For this high resolution, that's why I have this line. Yes. For this high resolution, we work with matching functions. It's only interesting for if you have a real plan, a large memorial painting or a painting. Yes, it's not for architectural objects. Okay, if you work with point cloud, it's only 1 to 50, 1 to 100 more. Maybe 1 to 20. And CAD drawings, I make the definition of surveying or stereophotogrammetry of architects, and maybe you can work 1 to 20, 1 to 10 with, but by architects 1 to 50, 1 to 100. Okay, and if you work with rectification and montage to get a large image plan, then you must stop by 1 to 10, 1 to 20 with measurement of distances. You need coordinates, or you need matching functions that you say, okay, I make an overview image of 1. If it is possible to take 1 image, then you can say, I make detailed images to make matching functions. In the training, you will see that I have examples. Okay, now we speak about the decision to the image rectification or 3D auto projection. The reality is, I think, 80% we work in 2D with only 2D image rectification. And in the segment of memorial paintings, we mix 90% of our 3D auto projections for sailings, yes, and for curved surfaces. In this area, we mix the mean work with 3D auto projections. If we work on a facet for stone conservators, we make 2D image rectification, not more. We can compare this, yes. Okay, 2D image rectification, we have only 1 plane on the surface. In 3D auto projection, we use for multiple curved surfaces or for heavy structure objects. And if I'm really interested to get a mosaicing with a lot of images. If you have a lot of structure at the object, it's also difficult to make a mosaicing, yes. In the next step, for image rectification, I need geometry or control points, and I need photographs with high resolution. For auto projection, I think at the beginning I need the same control points, only control points, because I need the control points for the photogrammetric orientation of the images. I cannot calculate the orientation by distances. I need the 3D coordinates. We take the same photos for auto projection, and then we need, and this is depending on the size of the project in Germany, I must pay 3,000 or 4,000 euro depending on the size of the object to get a ready surface model. That means 1 or 2 persons come, they make the scanning of the stadium of the church, maybe 1 day or 2 days, and they calculate the orientations. They calculate the triangulation. I need the surface like triangulation, not only the point cloud, and then I use it. I measure the control points for them that I know they calculate the scanning data in the same coordinate system like my image orientation. It's important. We can calculate the surface model also on digital stereo photogrammetry or for structure for motion. It's also possible, like Archisoft or 123 CAD. Normally, they have the same bad quality like scanning data. For a lot of universities, it's easy to take 50 or 100 images, and they are happy if they have a rotating object in the website. But it's not good enough for documentation and conservation. Sometimes I use the surface model, but normally, for me, it's cheaper to take data by scanning. Okay, and for the scale 1 to 1 until 1 to 10, it's not possible, it's today not possible, to work with the result today of laser scanning data. It's not good enough. Normally I say 1 to 20, not more, for auto corrections. Okay, in this relation I say I have costs 1 to 3 for 2D image rectification or 3D auto corrections. So the quality, the 2D image rectification, every time I have a high quality, and it's very easy to, you can do this alone. For 3D auto correction, the quality is connected with the quality of the surface model. Sometimes you have round edges with mistakes of 1 or 2 centimeters, and then I come with an image with a resolution of 0.5 millimeter, and you see these problems in the image. And it's important to know before. And for the field of conservation of stone, yes, rectification to a medium plane is enough. For small objects, they can do this alone, they have no costs. And the disadvantage, it's clear, it's only one plane, and you have perspective. But in the stone conservation in Germany, if you have 3D objects, you must go to the object and you must measure the profile line by hand 1 to 1. If you try to maybe to reproduce the profile line. You cannot take the orthophoto, you cannot take the image plan, it's not good enough. You cannot measure in a plan 1 to 20 or 1 to 25 a reconstruction of the profile line, you must use that subject. And that's why you don't need auto projection in the area of stone conservation. Okay. This is, I have find this slide, you can read it. So I can drink water. Okay. Some short examples, you know this example, I can go to the next, yes. I have also seen this. Go to the next, you have seen this also already, go to the next. Now we speak about mosaicing of the images. It's necessary if you order the image plan that you say, okay, it's not enough to make the rectification of the single images. You must make the mosaicing in Adobe Photoshop or maybe GIMP, that you get the color correction and that you have no differences in the overlaying area of the images. Sometimes you have a deformation in the walls and you go to Adobe Photoshop and make small corrections in Adobe Photoshop. It's not every time a correct result depending on the surface of the object. Yes. And we speak about the layout. Normally we say you need the grid courses and you need the scale bar in the layout. You need both. Because you have programs, some people take the images, they make the changing of the resolution, or by printing out a PDF file, they make adapt to paper size, and so you have a form scale in the image. If you have the courses, you can control the scale in 2 directions. If you have only the scale bar, so you can only control in 1 direction. And then normally for photogrammetry we use courses around. And if you use the mapping software, you need 2 minutes to define the courses, not more. For us, it's a documentation of the scale. 10 years later, somebody gets this image. You can control the size. And then you can start with the map. Yes. Some people take the image, make the mapping of 3D, and then they call us the image is wrong. How can we change it? Yes, at the beginning they save 5 or 10 minutes working time, and later they speak about 3D sets and more. Okay, we speak about file formats. We use since 1990, we work with TIFF. Okay, but at the beginning we speak with RAW, with RAW. Normally, in my opinion, with the RAW format in our office, they were developed by the photographer. He has the information of the situation on site. He take a developing program, he knows on which place he have used the clay card or the color card, and he knows some problems with that. And on this information, he makes the development of the images and saves the files as a TIFF file. And then we have a stable format for rectification and so on. If I give the raw file to the customer, maybe for the archive, I think in 10 or 20 years he cannot use it. He has not the information, and raw is it in dynamically format. Nobody knows in 10 years there are so much changes for cameras, maybe they cannot read the whole format. So it's only, I think it's interesting for a short time today, if the customer say, I need the original raw file, so he can control the work of the surveyor. He can control the resolution of the original images, that there is not too much scaling on the sides of the images. It's interesting for you that you can control the work. I think it's important to say you will have the original image files. Okay, the next step, we speak about the image formats. We work with TIFF. We have the LCD compression, and it's with no loss of information by compression. And I know this format since 30 years. It's open, you can use libraries, and everyone can develop software with TIFF libraries. We speak about PNP. They have made some, how can I say, they have adapted this format for good usage for the hardware, for monitors and so on. So it's a little bit reduced, and they have no CMYK for printing out by analog assets and auditors. And so normally we do not use TIFF. And JPEG, so it's terrible. It makes a lot of education at universities. And I come to the students, and as they show me the examples, we make trainings with rectification, and they come with a camera and they give me a list of JPEG files. I do not understand why, yes? Every time if you save a JPEG file, you have a new compression. And every time you have a new source of information of compression. It's so easy to understand. You can take a photo maybe from a painting and you can save it 10 times and you can see the development. It's 10 minutes education in the documentation education, yes? I think the students should understand this. Okay, it's, you can use a high compression of JPEG, and so you can send mere file for, how can I say, for communication, for working process, that's clear, but not for documentation. This is also a nice joke. We get a lot of 30 minutes, yes? So it's okay. We get a lot of requests that the people say image plane have to be delivered in drawing format, in CAD format. It's wrong, yes. Because the CAD file saves only the connection to the image file and saves the information of position and scale, not more. The image file is by side. No CAD file integrates image data in the CAD file. It's not necessary. The image is on the. And so you can, if you lost the CAD file because the people 5 or 10 years later have not a CAD system to work with this CAD file, they have only a stable image files and they have not the information about scaling, positioning, and so on. And so at first you must say, the images have to be rectified and mounted and color balanced to one image plane. And in the second step, you can see the image plane have to be georeferenced in CAD file. And then you have only one images, and maybe if you have no CAD file, you have the crosses and the scale bar, and you can correct it at all. It's important. You need a navigation map that you see all the images. Normally, it would be fine, I say this, if the customer come to me, give me the navigation map and say, this is the work, please calculate the price. But I never get this, yes? Normally, it's a result of our work. And we must go out and we must calculate the work and then we get this plan. But to mix, and how can I say, we ask 2 or 3 firms for the price. And I think if we make a good contest to get the best price, I must do some things before. It's not, I cannot take the cheapest, we have lost a lot of information because we have only calculated the hard part of the work. Then we give money and we have only the hard part of the work. Okay, this is the conclusions for you. How large is my budget? What is the time schedule? If the time schedule is very short, I must look for the size of the firm if they can do this job in a short time, yes. Which level of details, it means which scale and resolution, depending on the project, and so on. Which camera is be used, yes, how control measurement, and the resolution and the scale of the product. And some technical information. That's all. This was the second presentation. 30 minutes home. I have control over my time. I close this. So, if we speak about Metigo Map, the first license we sell in 1999. It means the software now 16, 17 years, yes. And in this time, we work together with our customers for documentation. And so we have collected ideas from our customers in the time of 16 years. That means all the functions for image rectification, this is our own work, these are our ideas. But all the functions for mapping and evaluation and cost calculation and so on, these are the ideas from our customer. And so you can find a lot of ideas in this program. Sometimes you must only ask if it is possible. And then we say yes, it's possible. And this idea, this idea, yes. There are a lot of functions in this program. And so I speak about 4 parts. I speak about documentation proof to scale. These are the functions for rectification and so on. We speak about vector-based mapping, like in CAD. We speak about the data and the area analysis, and we speak about quantity cost calculation. Okay, we start with rectification. In the first step, you can start with a ready documentation. Maybe you have all of this. That means you can import large image files by TIFF or by PNP. You have a lot of file formats. You can import CAD files, drawing files, and DXF files. And you can take all paper planes, you scan the paper plane, and you make the escalation maybe to the scale bar. Or you go out and measure 1 distances and you scale the paper plane to 1 distance. It's very easy to use. If you have no documentation, you must work alone. At first, with 2D image rectification by geometry. We have to speak about the rectangles, the parallel lines, and the distance damage. And if you have only small 3D objects, you cannot use the rectification. You go around, you make 4 or 6 or 8 images, and you make also only the scaling by the height. It's easy to measure by the height, and so you can put the images together and you make the mapping nearly to 1 scale. You need 10 minutes to make 4 or 6 scalations and put them together, and you can start to do it. Okay, image rectification by coordinate. It's interesting if you have already this plan, then you can measure points in this plan, you take your image and you can make rectification. Or you can order this plan. This is an example for rectification. You have this wall and you have the images. And you see it's not good to see the coordinates, and you see the result. You can do this alone, define only the rectangle, measure the width and the height, and it gets a rectification. You have seen this before. This is an example for the automatically rectification of details. It means you load the detail image, and you must define the area for the searching of connecting points. We need this area that we can calculate the scale between the two images. It's important for the matching functions. And then we start and try to get the points. And sometimes, how can I say, the matching functions work with the grayscale image. It's not a problem if you have some mistakes in the column, or if you have a historic image, it works. You can also use UV light images, it works too. But you cannot work with X-ray images, it's not possible. And also with infrared, because the structure of the grayscale is changed by the filter of the spectral light. Yes? That means X-ray or infrared, you must measure your own points. And sometimes we have problems for too much changes on the painting. And then you must search by manual measurement for points. And if we measure the coordinates automatically, then we know the position of the image. It's a very easy example. You see a small church, you measure the distance of the width and the height, you make the rectification of the first image. And then you take the images with a higher resolution and for every window, yes. And you see, so at points we have found all these points, and we take for every square 1 point for rectification. The first image, 5 images, you make the multi-layer TIFF export to Adobe Photoshop, you make the color correction. It's very easy. Maybe you need a little bit training. It's more important to take good photographs. Rectification, you can notice. We have a function for distortion correction. That means this is our training room. If you come to Leipzig, you can come with a camera. Or you take one wall of your institute. You can download this chess plate as a TIFF file on our website. And then you print it out, and you can put it on the wall. And then you take one image, and then you see we use the chess plate to calculate the distortion of the lens. And for every lens, we save the parameters of distortion. And then you have a list of cameras with different lenses, and you go out, take the photos, and come back and say, today I have used Canon 5D 24mm, and make the distortion correction before rectification is involved. You must make the correction before. It's an example for thermographic. So you have 2 infrared heating lamps. You see the wall painting, so the medieval wall painting. And they have a small camera and small infrared camera. And they heat the surface. Not much, only 2 or 3 degrees. Normally in summer you have more changing in summertime in the church. They do this in winter time, as the wall is cold. And at first they make the rectification of the daylight image. And then they use small control points with a little bit cool, maybe it's a temperature of 10 degrees, that you can find the points in the infrared image, yes. And so you can, maybe after 30 seconds, you take the image, the next, and the next, and the next. And now you see the places where the heating from the lens is, how can I say, collecting on the wall. If they have a good connection to the wall, the heating is going in the wall. Or if you have a changing of material, maybe a wooden part or steel, yes, it's going gradient. So you can analyze maybe the parts of the painting who have lost the connection to the wall. Or a changing of material, yes? And you see this are only 2 degrees, not more, 2.5. It's possible. We have prepared for 3D mapping, but at the time it's not scale. Now we speak about the mapping, the vector-based mapping. That means we have mixed rectification to the image. We know the scale of the image. And we scale all lines, all points which you measure on the images. we scale to the scale 1 to 1. That means inside of the project, we save the coordinates in the scale 1 to 1, like in a CAD system. And on this base, we can calculate the area, the length of the lines, and so on. That means you can combine images with different scales. It's possible. Maybe you have a historic image scale 1 to 100, and you have a documentation of scale maybe 1 to 20. You can combine these images in one image. We scale them to the project size. And we have a lot of drawing tools like in CAD system, polygon, freehand lines, circles, and cubic splines. We have function for cutting lines, cutting areas, and so on. And during the mapping, automatically for every element we calculate the area, the circumstance, or by the line we calculate the next. We do this automatically in the background. You can switch it off or you can switch it on. This is the class management. Let's look like the layer management in CAD. Yes. We have a special thing. If you create a new class for mapping, you must make the decision, is it an area mapping class or is it a line mapping class? Or is it a class for annotations or for symbols? It means you cannot combine different elements in one class. At the beginning we get the question why. And at the end, you understand, because we have clear classes, only these areas, only these lines, you can get a clear report. How many elements, how many scales, how many elements, how many meters. Every element has the same color and the same hatching like in the class definition. In AutoCAD, every element can get a new color. But you cannot change automatically altogether. You have programs to change the colors and the working style. So we have in the class management, you can change colors, hatchings, and automatically we go to the mapping and change all elements of this class. So you have the same viewing like in the class management. And you can define much more information. Every class can get his own data fields. Maybe you make the area mapping, you give the information for the deep, and so we calculate the volume. Or special informations about the accuracy, how many sites is into the point and is a decimal point. Okay, we have a group management. If you have a large project with classes for material, for damages, and for documentation of the work, you can define groups. So you can maybe 20 or 50 groups, you have free choice. You can create different combinations of damages, of materials, and so on. It's very easy. You need 1 minute or 2 minutes to define a group. You create the name, you select some classes from the project, and then you can say, please show me this group, or the next group, or the next group. And so you can learn to understand the combination of different types of damages, material, and so on. Okay, you see the legend. The legend is connected with the class management. That means these are the hatchings and the colors and the name of the class. If you change the class management, we change automatically the legend. And if you switch it on, then you can see how many elements or how many square meters. If you switch it off, you don't see this. Sometimes you need this and sometimes not. At the beginning, I say you must start with a small project to understand how the program works. And later you can work with large projects. We have a hierarchy. That means we have one mapping template. Here you can define the classes, the colors, the hatchings, and the units, and so on. And all the other projects are connected with this template. And if you make some changes, you can say adapt to all projects, and automatically all projects have the same viewing like the template. You can create this navigation card. It's for good working, I can say. You can define the position of the projects. You can select the project, you see the overview. In the next step, we use these link areas to show the content of the project. Maybe you have define the mapping area, and we calculate for every project maybe how many persons related to the mapping area of this project. So you can combine the intensity of special damages for this project. You can select one type of damage, and you see the different type of colors. So you can try to understand why we have in the north or in the south or in the west more damages of this type. Yes. And we do this automatically. You have to make the mapping. You must understand, if you make a mapping in Adobe Photoshop, you have the color image. If you make mapping in CAD, you have the same. And we say we have this mapping and we use it for evaluation. You can do more with this. It's not only a color image. Okay, this example for stone conservation. Yes, you can go to the hierarchy. You select one class, then we give you the list over all projects, how many prices in the class, and how many elements together over the whole project. And so they have control about the costs during the work. One day in the week, someone goes out with a tablet PC and makes documentation of the work of this week. And so on Friday, he can say how many we have done. And he can calculate the invoice and so on. So you can do this. Now we speak about data and area analysis. We have user management. It's nice to speak about this. We save since version 4. For every element, we save the date of creation, and the date of the last changing. And we save the user who creates the element and the user who makes the last change. And normally we think it's a good thing. Maybe you have a painting, every year you have 2, 3 or 4 exhibitions, you have a condition report, and so you can ask who makes the mapping of this damage. You can ask him about the reason and so on. Or maybe you have a large stone facade. You can analyze which mappings on which week. So you have control about the development of the project. But normally the conservators don't use these functions. They like to make the mapping anonymous, I can say anonymous. But if they write the invoice, they write the name of the invoice, yes. For the mapping note. It's very easy, you can create 3, 4, 5 users, and every time if you open the project, you ask which user. And you can switch the users, and you can also define different rights to the user. That means you can say every user can change and delete his own elements, but you can protect the elements of the other users. And so maybe the first conservator makes the report of the condition. And the next conservator, who is responsible for the costs, he makes the plan of the work. And so he cannot change the condition. Because he says it's too expensive, some things we have not found. And the third conservator makes the documentation of the work. He cannot change the planning of the work. Understand? That's very easy. Okay, user management. We have in data analysis of the mapping, maybe the simple thing is you can take one mapping class. You can define special code depending on the size of the elements. Because for small areas, you have another cost calculation like for large areas. For large areas, you need more material. For small areas, you need more working time. And you can switch on and you see the result, and then you can copy this to different classes. We have an area analysis. In Germany, we have some special cathedrals, and they have made drawings with the stones, and every stone has a number, that means every stone has a name. And so they try to make the documentation of the conservation history of every stone. I think it's too much money, too much work. and maybe they do this 5 or 10 years, and later they will finish this, I'm sure. And what can I say? Earn a lot of money, yes. And so we have developed this function, and maybe if you have makes the drawing of the stones, you can make the mapping. It's not necessary to connect the information to every stone. And we make only the analyzing of the overlapping area. That means you can select one class, maybe quarter, and then you can select some damages. Then you can say, analyze, please show me all stones with the material limestone and the overlapping with a special type of damage, so that you can find the places where you must do some work. And now you must think, what can I say? You must write the horizont. Now you draw no stones. Maybe you say, I have a scaffolding, and for the first and for the second and the third floor of the scaffolding, you draw one rectangle. So you can ask how many material, how many work I need for every plan of the scaffolding. So you can organize the work. Yes. The next example is, maybe you have to make a mapping of materials, different stone types on the facade. So you have to make some changes, so you have different stones. And so you use the different types of materials to analyze on which type of material I have special combinations of damages. So you select at first material A and say, please show me all stones of this material with this special type of damage. So you can analyze the condition. Yes. You have the function of the program, and you must learn to define the question. Understand this. It's like a information system. Okay, this is the result, and the result is the mapping, and so on. Now we speak about quantity and cost calculation. German are very organized. And so we have a lot of control about cost calculation. This is a special German interface for exchange of costs information by large projects. That means before they start to build a building, one architect defines the parameters, maybe how many stones and how many working time and so on, and they create the SCAP file. And then they send the SCAP file to 5, 10, 20 firms, and the firms must write the prices for material and working time in the SCAP file. And then we collect these files together. We have, I think, over 20 different software development firms who produce software programs for this SCAP file. It's a very large marketplace. And they earn a lot of money. And then you can compare the cost calculations by material, by working time, and can think about what is the best solution for our project. Maybe if it is a long project over 5 years, we must think about changing the cost of materials. As if it's only a short period with not much material, then you can look for the working time. So we use the SCAP file. That means you can import the SCAP file, and then you can make the mapping in the position of the SCAP file. That means the firm makes the cost calculations, they have the contract, he imports the position of the SCAP file, and they make the documentation of the work in the position of the SCAP file. And so they can write the invoices or mapping and the layout of the SCAP file. For every element, we save an index. This is the name for every element. Yes, 1, 2, 3, 4. And you cannot change this number. That means in every mapping class, maybe stone exchange, we count all elements. And if you delete number 11 will never come back. The next is number 12, number 13. And so every element is a fixed position in the calculation of the cost for the invoice. And we have different types for calculation of area mapping. Maybe you draw a polyline, and we use a polyline for calculation. The next one is you can we calculate the smallest rectangle around this polyline. Because the people say it's a nice polyline, I never can control this area. I have not the possibility to control this area. So they say we take the smallest rectangle around. You can measure the length and the height, so you can calculate the area alone. And the third step is the people make control measurements by hand, by manual measurements. You go out and measure the height, the height, and the deep. And they make the protocol. And you have this dialog, you can write these measurements, and you can export to a Microsoft Excel file. You see the index numbers, you see the measurements, you can calculate the costs. It looks like a lot of work, but it's if you how can I say, if you have a good organization of the data in the program, it's not much work. Other people take paper and count the elements and sort them, and if they must change it, they start again. Yes. Sitting in CAD and draw and count the elements on the surfaces. And the last development is, how can I say, a cost calculation, a module for cost calculation. It's interesting for stone conservators, yes? In the first step, you can define special information for working time. You have different types of qualifications on the project. And so you have different cost calculations for 1 hour or by minutes, yes? Then you can define the costs by material, and then you can define the costs by equipment. And then you select one mapping class, maybe stone exchange, and you can say, I need 3 steps for working time. I go to the project, I must cut the stone. Then I go down and I must prepare the new stone, and then I go back and must put the new stone in the wall. 3 steps. Then you must calculate the material, the stone, depending on the size of the mapping, yes. And maybe you need a little bit lime to integrate this in the wall again. And then you need equipment to cut the stone in the wall and to prepare the new stone. Then you make the mapping, maybe for 5, 6 elements, and we automatically calculate the costs for material, for working time, and for the usage of the equipment. You do this automatically. You make the mapping for the documentation. And it's not to prepare the offer. I think it's good to understand after the documentation project. You have finalized the project, you have to do a lot of work, and you must do the documentation of the work. As a German, you must do this. I think you're awesome. That means you make the mapping. And now you have defined for one time the parameters of the costs for your firm. So you can every time after the project look of the information, how many working time I have need, and how many working time I have calculated before. And you can learn to understand the costs. The main work is the mapping. You must do this in Photoshop, in AutoCAD, or in our software. But the result of the information is more. You must learn to understand it. And you must learn to, how can I say, to use this information for your own work. And no conservator uses all the functions with this program. Everyone must select the special functions which you need. Yes, no use of all. And there are too much functions. Developed in 16 years, and this are not now ideas. Okay. I have finished the time, right? Thank you. We have some questions or not? Too much information?
Quite a lot of numbers.
I think a lot of people come to the trainings in the next days. Yes, all of them, yes. Yes. I think for me it's very interesting if you bring some images of your own work, so you can speak about this. For the training I have some German projects, maybe it's nice to see different objects. But I think it's very interesting if you give me on a USB stick some examples, and then I can look at the images and I can show you some things how you can build this. Yes.
Are there some specifications for the images we can bring, like the format, give measurements? Or?
Yes, I think at the beginning you come only with the images for the first day, and we speak about this. And next week we will see again. And so you have time with the knowledge of the first training day to take the images, to make your own measurement, and to make your own measurements without me. And next week, Thursday and Friday, we can speak about this. We can speak about the problems and so on. And so I think that's a good organization that we make the training, you have time to test it, and 1 week later we see again. I think it's good. Okay, next question. I accept JPEG and TIFF files for the training, it's no problem. No raw files, I cannot read raw files in Metigo Map.
Can you wear the translator so that they can translate the Pues primero, en primer lugar, agradecer la plática del día de hoy. Pues ya nos seguiremos viendo para adentrarnos en este programa. Pero sí, tenía la duda si necesitamos como conocimientos previos para poder manejar el software. Es decir, vemos que hay todo un tema de fotogrametría que tiene que ver obviamente con toda la teoría y práctica en el tema. También el tema de dibujo, el dibujo arquitectónico, que bueno, al parecer en las pantallas es muy parecido al CAD, pero tendrá también sus diferencias. Y bueno, y por supuesto ya todo este último módulo de costos y cantidades, ¿no? Entonces, pues a ver si alguien que no tiene a lo mejor las nociones de estos 3 módulos, vamos a estar en condiciones de aprender a usar el software, o es un software tan noble que que sin tener esos conocimientos vamos a poder utilizarlo, pues obviamente con práctica, pero pues sí tenemos esperanza de aprender a usarlo pues en estos días.
There are different things, yes. At the beginning, it's clear you must start with simple projects. It's normally you must learn to get a feeling how you can make simple rectification and how you can organize a small project. And for these steps, we have tutorials on our website. And we have training examples. You get these training examples in the next days. And so you can look at tutorials and you can make these steps also alone. It's possible. For the future, I think maybe you know Jacinta. I think in winter time she comes to Mexico. Jacinta? You know Jacinta? Jacinta, yes. I think she was. And I think she comes every winter time to Mexico and summertime. She works in. And so you have, I think, a continuing support. And for me, I think it's a little bit depending on the interest for our software. I come back maybe one time or every 2 years, yes. And I think it's also a question for universities. I think there are a lot. They should have teachers who learn to work with our program. And German conservators are also no specialists in digital mapping, as they start to learn by zero. Yes, I think it's not difficult. At the beginning, you are a little bit afraid about so much functions. But it's wrong to think about so much functions. At the beginning, you must say, which I need for my own work, in the first steps. And then with every project, you learn to do more. You understand more and you do more. It's a process of development. And it's no good idea to start with a large project. Because if you work on a large project, you have a lot of you have a lot of problems with a large project, and you have no time to learn the mapping software. And so at first, sometimes I say to the people, please take the mapping from the last year and repeat it. And so the head is free to concentrate to the mapping. Yes? And so you must be careful at the beginning, step by step. You have studied your things, you have enough information that you have to use the program. I think so.
Muchas gracias. Por lo que yo puedo entender en la presentación, el software combina las virtudes de los programas de imágenes raster con las de los programas que procesan información de vectores. Al principio tenemos que alimentar al programa de una imagen raster controlada en el sentido de la resolución y una escala. El programa controla una escala y genera los mapas y genera los mosaicos. Y ya sobre esta imagen hay la oportunidad de dibujar vectores y el programa nos entrega cuantificación del tamaño de estos vectores. Bien, ahora en algunos materiales del tema de la conservación del patrimonio, los objetos a analizar tienen formas orgánicas. ¿Cómo es que se puede hacer este tipo de dibujos en el software? Sí, que no tienen formas geométricas de polilíneas, sino totalmente orgánicas. Por ejemplo, una grieta es una forma difícil de dibujar en el sentido de dibujarla con vectores. O cuando se pierde una parte del aplanado o una parte de la capa pictórica, no necesariamente esto se puede englobar en una forma geométrica, sino la forma es orgánica. Entonces, el dibujo debiera de ser a mano alzada. O sea, hay la posibilidad de conectar al programa a una tableta, por ejemplo, y dibujar sobre la tableta. Esa sería la pregunta. Y por supuesto, si el programa puede calcular la forma orgánica, ¿no? El área de la forma orgánica.
Esta tu grieta.
You must find the compromise for the users that you have spline functions. You have also functions for a freehand line. Yes, I follow the line. If I select the spline functions, I can correct the points, yes? If I select the freehand line, it's like in Adobe Photoshop, it makes no sense to change the surface, yes? So you have a polyline function, yes, and you can combine this line types, yes? That means I start with a polyline. It's okay. It's a process of learning, it's clear.
Hola. ¿Es compatible Metigo con programas? ¿Es compatible Metigo con programas BIM como Revit?
You can write the mapping in a CAD format, like DXF drawing file format, yes. But you have not all information about the mass calculation and so on. And this drawing export. And sometimes in Germany we have projects where the conservator must give the mapping in a CAD format. That means you make the mapping, you finish the mapping, and you can do project, export, CAD drawing DXL. You can select the classes which you are interested, and you can select maybe the type of the AutoCAD format, and you can write out. Yes, but it's not. It's only one way. Because by writing export, we lost some information, so we cannot change in CAD and come back, and it's not possible. You can import also from CAD drawings. We analyze the classes and say, okay, this is the class by area mapping, and you can import CAD mappings. To continue the work, yes. But you cannot mix the dynamically exchange. Maybe if you work with CAD, you can use the rectification functions. You make the rectification, and then you make the export of the rectified image to a drawing file, and then you can make the drawing in CAD. Possible.
I have a question about how do you do the first or the initial mapping? In terms of let's say this, I have the photographs, I have a very good resolution photographs, and then I have an AutoCAD drawing, but I don't have the total station points of all these, let's say, this element that I want to map. So may I start with using the photographs and the AutoCAD drawing, and then later I can integrate all the total station points once I take them? Or does this have an impact or an influence into the scale and the resolution that I want to get, which is 1 to 10 or 1 to 5?
I see you have three choices. For me, yes, if I would do this, I would measure it first, coordinates my total station, and make rectification, because for me it's the highest algorithm. Do you understand?
Yeah.
But you can also take at first the CAD drawing, because you have not asked. This is the only way for you, so you make the import of the CAD file. Maybe using the project tree. And you can import image files, you can import CAD files, yes.
But what I mean is, if we do have this information already, and then is it possible later to integrate what we need, which is in this case for the rectification?
There's a small problem. you use the CAD file with some mistakes and you make the articulation. And then you make the mappings. Maybe you can change later the images or the mappings on the position. Do you understand? On the first images. And so I think maybe if the CAD file is good enough, then you use this step.
So what is good enough?
What is good enough, yes.
Yeah, that's a question because
I do not know your CAD file.
yeah, well, I don't know how to take a look and see, but if it's good resolution, it's I don't know how to say it. I don't know exactly, but I will know. Yeah, sure.
But you can test it. I have told you the example, yes. If you use the CAD file and you take the overview image, maybe for a larger part, and then you can look how it works. It's very easy to show the mistakes or the architect drawing. Bring the example in the next page.
Yeah, no, I'll have it, yeah. I'm ready. Bueno, vamos now.
Es una pregunta muy veloz. En el caso de las nubes de puntos del escáner láser, ¿el programa lo lee como imagen o sí te lee como un modelo tridimensional?
Two ways. If you are interested to make the mapping on a 3D surface file, then you can import the 3D object, like format STL or VRML. STL is the grayscale surface and VRML is the surface with colors.
La segunda de una superficie de colores.
Since 1 week we have the Spanish version. And I go to surface model and I can say, in the surface model I can select the file and then I can use this STL file or PTS or VRML. We have some formats for the surface models. And you can use the surface model to calculate an auto projection. So you can also make in Metigo Map the mapping on auto projection. That's one way. And the second way is maybe some architect office makes data scanning. So you can say, please don't take the point clouds with all the problems. Ask for the auto projecting point clouds. And so you get into 5. And so you can load the relative file with scale and you use it to measure points for your own application. That means you can import 3D surface models and can calculate auto projection, or you can make the mapping of the 3D surface. I think it's too heavy by the data. And it's more interesting to take the auto projection, measure coordinates, take your own image in your resolution that you need, and make some new rectifications. I think it's the best compromise.
Qué bueno, pues muchas gracias. Muchas gracias por su presencia el día de hoy. Si alguien tiene dudas acerca del grupo que le ha tocado, los 50 participantes que estamos aquí vamos a estar divididos en 4 grupos de 12 o 13 personas. En la invitación ustedes recibieron qué días son los que tienen que estar presentes. No es necesario que traigan equipo, ya que las máquinas ya están en la sala de consejo del ENCRyM, ya tienen el programa cargado, tenemos los nombres listos, entonces ustedes solamente tienen que venir con algunas de las fotografías para que las revisen y sobre todo en la sesión larga vamos a trabajar con las imágenes que el señor Sid les trae para trabajar sobre ellas y ya después, como lo habíamos dicho, primera sesión, conferencia. Segunda sesión es el training basado principalmente en las fotografías que trae él. La tercera sesión, él va a estar en Oaxaca impartiendo otro curso, entonces mientras tanto nosotros vamos a hacer un trabajo de prueba para poder aplicar los conocimientos adquiridos en el training y ahí entonces se van a generar cualquier tipo de duda o pregunta necesaria. Y luego ya el jueves y el viernes nuevamente hay otra sesión en donde él va a estar presente y podremos entonces resolver las dudas que tengamos al momento de querer aplicar el programa. Si alguien tiene más dudas, están bien comentadas. Digo, más dudas acerca de la organización. Bueno, pues muchísimas gracias por todo y nos vemos entonces en la misma sesión.